So I'm Luke Zoet. I'm a professor at UW-Madison in the geoscience department. I'm broadly a geophysicist, but one of the things I work on is coastal erosion. This is just a picture of a subset of my group, the people that work mostly on coastal processes. We're rolling on the left. There's from the Geologic Survey, and the other four are grad students I have that are doing various types of numerical modeling and field work and things like that. All right, go ahead to the next slide. Okay, so I thought, this is on communication, but I thought I'd start out by just sort of telling you some of the things that we're doing in the group here. As we all know, the lake levels are fluctuating. They're high right now. That's causing lots of erosion. We're trying to figure out what are the mechanical processes that are driving this erosion. How can we better model them? How can we better simulate what's going to happen in the future? We do a combination of things, numeric modeling like on the top, where we take hill slope stability, offshore hydrodynamic models, look at how they move sediment around, how that leads to erosion, do field observations. That thing on the bottom left is actually a digital elevation model we made from various drone imagery that then we can use to constrain some of these modeling techniques. We also build big experimental devices like that thing on the right, which is a thing that is made to simulate how ice deforms. We have a giant wave tank we built on a freezer that can simulate cold coasts and how cold coastlines are affected by hot wave action and how that differs from coasts you might see in North Carolina or something like that. Next slide. So, a couple of findings. One thing we've been able to find is through these combinations of field observations and numerical models in particular, we can combine things like drone observations, groundwater flow models, hill slope stability models, and different engineering properties to begin to figure out where these bluffs are failing and how that's propagating through time. We've modeled several different bluffs of different heights, and we found that the landslides on the bluffs in particular are propagating up, but they're not immediately going to the top. And in some cases, they're still working their way to the top. A lot of these communities that are situated on high bluffs still aren't feeling the erosion at the top yet. So it's going to be a sort of a rude awakening in a couple of years when the erosion makes it all the way to the top in those cases. This is a paper we had in JGR that just came out a couple weeks ago. Go ahead, you go to the next slide. So here's two more papers we have coming out. The one on the left is more observational. So we just repeatedly scanned bluffs with drones and built models to look at when they're falling apart. And then this thing on the right is by my grad student, Colin Rowland, who's in here. And he did some pretty sophisticated groundwater hydraulic modeling to figure out what's driving the slope instability. Just stepping through time there, what he finds is that the time where we see the maximum erosion on the bluffs is in the early spring. And that's because at that point, the pore water pressure in the bluff is the highest and the shear strength of the bluff material is the lowest because it freezes in the winter. And then when it thaws out, you have a weak bluff face material, and you also have high pore water pressure, which when combined leads to lots of failure. And so there's a seasonality in the failures here that you don't see in other climates simply because of the fact that it freezes in Wisconsin and makes the coastline behave somewhat differently than you can expect to find in North Carolina or something like that. Go ahead to the next one. Okay, so focusing a little more on the communications, what groups have we talked about? Well, we interact quite a bit with Wisconsin Coastal Management Program, specifically their hazard works groups. So there's a lot of community planners from the different sort of counties around the state that are concerned about this, that are in this group. And so we can directly talk to them about what they might expect, things they can do to help mitigate it, things they can do to sort of protect their properties along those lines. Wisconsin Department of Natural Resources. So Colin and I led a sort of a workshop for them to help them understand how to permit coastal protection and revetments better, about the types of things they can do and the ramifications that would come out of that. We worked with lots of county officials, parks officers, other types of people from around the state to help them understand, what could happen if maybe they're situated on a high bluffs like in Ozaukee County in Wisconsin, or maybe they're on lower bluffs like in Racine, in trying to help them understand sort of the concept of how this erosion is going to play out and types of effects. Okay, go to the next one. One quick slide left. Okay, skip it. Here's a photo. This is one way to communicate with people. This is a video that's supposed to be playing. There it is. This is the best way to communicate with people. Show these giant landslides. So you can see that truck on the top of the thing. That's a landslide that Colin took a video of off the Wisconsin coastline. It's huge, right? If people were down there, they would be dead if that fell on them. And that's an active beach. You can see people walking around down there. this is not only a hazard for people like living in this area, but also people that just visit the area because of sort of, sometimes the danger associated with these large scale failures that we see. I don't think I have another slide, but you can advance it. Oh, okay. The one takeaway point here is, at least in these bluffs, even after the lake level goes down, this erosion is still going to keep going on for years because it takes a while for these things to make their way to the top, and people live at the top, and so some people don't even know it's coming yet in some instances. So I'll leave it there.